The bomber was losing fuel at 3 gallons per minute, and Frank Luke had maybe 40 minutes before the B-17 would run dry and crash short of the English coastline. He stood in the repair hangar, watching hydraulic fluid pool beneath the aircraft's damaged wing tank, calculating whether leather could hold aviation gasoline long enough to get the crew home, or whether attempting the repair would kill everyone when the improvised tank ruptured at altitude. The metal tanks that should have been used for this repair were stuck somewhere in the Atlantic supply chain, delayed by submarine attacks and convoy schedules that prioritized ammunition over spare parts. Luke had leather in the hangar because it was used for tool pouches and equipment covers, had sewing equipment because parachute repairs required stitching capability, had absolutely no authorization to attempt fuel system modification that would violate every safety regulation that kept aircraft from exploding in flight. The B-17 had limped back from bombing raid over Bremen with flak damage that had punctured 2 fuel tanks and killed the ball turret gunner. The pilot had made emergency landing at the American repair base in Suffolk, where Luke worked as senior mechanic responsible for keeping damaged bombers flying, despite parts shortages that made standard repairs impossible. The damage assessment showed the bomber needed new fuel tanks, but the replacement tanks wouldn't arrive for at least a week, and the bomber group needed every aircraft they could put in the air because losses were running at 15% per mission, and replacement aircraft weren't arriving fast enough to maintain operational strength. Luke's commanding officer had been direct. Find a way to make the bomber flyable, or accept that it would sit grounded while other bombers flew missions without adequate numbers to maintain defensive formations that kept crews alive. The pressure wasn't subtle, and the implications were clear. Mechanics were expected to improvise solutions that standard procedures said were impossible, were expected to accept responsibility for innovations that might work brilliantly or might kill people, were expected to choose between certain grounding and uncertain flight, rather than having the comfortable option of following regulations that assumed adequate parts supply. The leather idea had come from observing how saddle makers constructed containers for liquids, how properly treated leather could hold water or oil without leaking if the material was thick enough and the seams were sealed correctly. Aviation gasoline was more volatile than water and would dissolve many adhesives, but Luke thought that heavy leather sealed with natural resin might resist gasoline long enough for a single flight. The concept was absurd and probably suicidal, using flammable material to contain highly flammable fuel in aircraft that operated at altitudes where any leak could cause catastrophic fire. But absurd was becoming standard when parts shortages made standard repairs impossible. He tested the concept on ground using leather samples and gasoline drawn from maintenance supplies. The leather held gasoline without immediate leaking, but the seams began weeping after 30 minutes, began showing signs of chemical degradation that suggested the gasoline was breaking down whatever compounds kept the leather waterproof. Luke tried different sealants and different stitching patterns and different leather treatments until he found combination that held gasoline for 2 hours without significant leakage. 2 hours was barely adequate for the mission profile. Bombers typically flew 4-hour missions, but 2 hours might be enough to get damaged aircraft home, rather than having them crash in the channel where crew survival was nearly impossible. The testing consumed 3 days that the bomber couldn't spare, 3 days when the aircraft sat grounded while its group flew missions short 1 aircraft. Luke's commanding officer was growing impatient with the delay, but was unwilling to order Luke to install untested fuel tank that might explode and kill everyone aboard. The tension between operational necessity and safety requirements was constant struggle in maintenance operations, where every decision involved calculating acceptable risk levels that peacetime standards would have considered criminally negligent. Luke decided the leather tanks were sufficiently tested and began constructing the actual installation that would replace the bomber's damaged metal tanks. The construction required leather thick enough to withstand fuel pressure, but flexible enough to fit inside the wing structure where rigid tanks couldn't be inserted. He measured and cut leather pieces that would form tank walls, stitched them together using techniques borrowed from saddle making, sealed the seams with resin compound that testing had shown would resist gasoline dissolution for at least 2 hours. The tank looked crude and improvised because it was crude and improvised, looked nothing like the precisely manufactured metal tanks that engineers had designed for B-17 fuel systems. The installation required removing damaged metal tanks and fitting leather replacements into spaces that weren't designed to accommodate non-rigid containers. Luke had to construct support frameworks that would prevent the leather tanks from collapsing under fuel load, had to route fuel lines to connect with existing systems without creating leak points where gasoline could spray onto hot engine components. The installation was part engineering and part craftsmanship, required understanding both aircraft fuel systems and leather working in ways that his training had never combined. He worked through night completing the installation, while knowing that dawn would bring decision about whether to test the tanks with actual flight or whether to ground the aircraft until proper metal tanks arrived. The pilot examined Luke's work with skepticism that was entirely justified given what he was being asked to trust. Luke explained the testing he had done and the 2-hour durability estimate, and the fact that metal tanks weren't available on any timeline that would get the bomber back into operation before the war ended. The pilot asked what would happen if the tank failed in flight, and Luke was honest. Catastrophic fuel leak that would probably cause fire, that would probably kill everyone before they could bail out. The honesty didn't make the pilot more comfortable, but it gave him information needed to make informed decision about whether to risk his crew on fuel tanks that might work or might turn his bomber into fireball at 20,000 feet. The pilot decided to test the tanks with skeleton crew, himself, co-pilot, flight engineer, and Luke, rather than risk full crew on untested modification. The decision was tactically sound and ethically complicated because it acknowledged the tanks were dangerous, while also accepting that they needed to be tested by someone if they were ever going to be used operationally. Luke agreed to fly as demonstration of confidence in his own work, agreed to risk his life on fuel tanks he had constructed from leather and desperation and incomplete knowledge about how gasoline would interact with organic materials under flight conditions. The test flight launched at dawn with 4 men aboard aircraft designed for 10-man crew. The emptiness was eerie and made the bomber feel more fragile somehow, made Luke more aware that they were betting their lives on fuel tanks he had assembled in repair hangar using materials never intended for aviation use. The bomber climbed to 10,000 feet, and Luke monitored fuel pressure and temperature, watching gauges for any indication that the leather tanks were failing or leaking or behaving in ways that standard tanks wouldn't. The first hour showed no problems, and Luke began allowing himself to believe the modification might actually work. At 90 minutes, the starboard leather tank began showing pressure fluctuations that suggested either leakage or structural deformation that was affecting fuel flow. Luke reported the problem to the pilot, who immediately began descent toward base, while maintaining altitude sufficient for bailout if the situation deteriorated catastrophically. The pressure fluctuations stabilized and then stopped, suggesting either that the problem had self-corrected or that some more serious failure was developing in ways that gauges couldn't detect. They landed with fuel still flowing and without any visible leakage or fire, landed having demonstrated that leather tanks could work under flight conditions even if they showed concerning behaviors that would need to be understood before operational deployment. Post-flight inspection revealed that the pressure fluctuations had been caused by leather flexing under fuel load in ways that temporarily restricted fuel lines, that the problem could be mitigated through better internal bracing that would prevent excessive tank deformation. Luke implemented the bracing modifications and conducted second test flight that showed improved stability and no pressure anomalies. The modification was working well enough that operational use seemed feasible if pilots understood the limitations and if ground crews monitored the tanks carefully for signs of deterioration that might require replacement before failure occurred in flight. The commanding officer approved operational deployment of the leather tank modification with restrictions. Tanks would be used only for return flights after combat damage had destroyed metal tanks, would be replaced with proper metal tanks as soon as those parts became available, would require pilot acknowledgement that they understood the risks involved in flying with improvised fuel systems. The restrictions made operational sense, but they also created administrative burden, because tracking which aircraft had leather tanks and ensuring proper warnings were communicated required documentation that maintenance operations usually didn't prioritize. The first operational use came 3 days later, when a bomber returned from mission over Hamburg with flak damage that had destroyed both inboard fuel tanks. Luke installed leather tanks, and the bomber flew again the following day, completed the mission without fuel system problems, landed with leather tanks intact, and showing no signs of imminent failure. The success encouraged other maintenance officers to attempt similar modifications when faced with damaged aircraft and parts shortages that made standard repairs impossible. The technique began spreading through maintenance operations as practical solution that violated regulations, but worked reliably enough that operational necessity justified the safety compromises involved. The technique's spread created tension with higher command levels who were responsible for aviation safety standards and who were appalled that field maintenance was installing leather fuel tanks without formal engineering approval or comprehensive testing. Safety officers argued that the modification was dangerous and should be prohibited regardless of operational pressures, argued that allowing expedient repairs would establish precedent that could lead to even more dangerous improvisations. Maintenance officers countered that parts shortages made improvisation necessary, and that grounding aircraft while waiting for proper parts meant fewer bombers on missions, which meant higher casualties among crews who flew without adequate defensive formations. The debate was ultimately settled by operational reality. The leather tanks kept working without causing catastrophic failures, and the bomber groups needed aircraft so desperately that safety concerns couldn't outweigh tactical requirements. The modification was grudgingly accepted as temporary expedient, with understanding that it would be discontinued once supply chains improved and proper metal tanks became reliably available. The acceptance came with requirements for enhanced inspections and mandatory replacement schedules that would prevent tanks from remaining in service long enough to develop failure modes that initial testing hadn't revealed. Luke trained other mechanics in the leather tank construction technique, documented the procedures in detail so that modifications could be replicated consistently across different repair facilities. The documentation emphasized that leather tanks were emergency measure, not standard procedure, emphasized the safety limitations and the inspection requirements, and the situations where the modification should and shouldn't be attempted. The technical writing was challenged because Luke had to describe improvised techniques precisely enough for others to replicate them, while also conveying appropriate caution about risks that couldn't be fully characterized through limited testing. The training revealed that leather tank construction required skills that not all mechanics possessed. The stitching and sealing required craftsmanship more similar to leatherworking than to aircraft maintenance, required patience and attention to detail that some mechanics struggled with under time pressures that made careful work difficult. Luke had to reject several early construction attempts by other mechanics because the workmanship was inadequate and would have created tanks likely to fail in flight. The quality control issue demonstrated that improvised solutions couldn't simply be described in procedures and replicated mechanically. They required judgment and skill that varied across individuals, and that determined whether improvisation produced functional equipment or dangerous failures. Over the next 6 months, leather tanks were installed in approximately 35 bombers at Luke's repair facility and at other facilities that had adopted the technique. The tanks were used for cumulative total of maybe 200 missions without causing any catastrophic failures. though several tanks developed leaks that required emergency landings before fuel exhaustion occurred. The safety record was remarkably good, considering the improvised nature of the modification. Was good enough that the technique remained in use even as supply chain improvements began making metal tanks more reliably available. The administrative burden of tracking leather tank installations proved more challenging than anticipated. Aircraft moved between repair facilities and between operational units in ways that made consistent documentation difficult, made tracking which bombers had leather tanks, and when those tanks needed replacement, nearly impossible without dedicated record-keeping that maintenance operations weren't equipped to handle. Several aircraft were discovered to have leather tanks that had been in service for months, beyond intended replacement schedules, were still functioning despite being well past the point where testing data suggested they should have failed. The discoveries created concern that maintenance tracking was inadequate, but also suggested that leather tanks were more durable than conservative estimates had predicted. The supply chain improvements that were supposed to eliminate need for leather tanks arrived gradually and inconsistently throughout 1944. Metal tanks became more available, but shortages persisted, and leather tanks remained in use as backup solution when metal supplies were exhausted. The persistence demonstrated that improvised solutions often remained necessary even after circumstances that had prompted their development had supposedly improved, that field operations couldn't rely on supply improvements being comprehensive or consistent enough to eliminate all parts shortages. Luke's innovation earned him commendation from his commanding officer and informal recognition among maintenance personnel who appreciated practical problem-solving that kept aircraft flying despite parts shortages. The recognition didn't include formal awards or promotions, because acknowledging the leather tank modification too prominently would have required explaining to higher authorities why field maintenance was violating safety regulations on systematic basis. The unofficial recognition was sufficient for Luke, who was more interested in solving practical problems than in receiving official acknowledgement for innovations that he considered obvious responses to obvious constraints. The post-war assessment of the leather tank modification was mixed. Engineering analysis concluded that the tanks had been more dangerous than field testing had revealed, that several near failures had occurred that could easily have resulted in catastrophic fires if circumstances had been slightly different. The analysis recommended that similar modifications should require more comprehensive testing before operational deployment, should require formal engineering approval rather than field-level decisions made under operational pressure. But the analysis also acknowledged that parts shortages had made improvisation necessary, and that prohibiting field modifications would have grounded aircraft that successfully completed missions using improvised repairs. The tension between safety requirements and operational necessity remained unresolved in post-war doctrine, because resolving it definitively would require either ensuring perfect supply chains that eliminated all parts shortages, or accepting that field maintenance would continue improvising solutions that violated safety standards when operational pressures demanded results that proper procedures couldn't deliver. Neither resolution was achievable, and military maintenance continued operating in ambiguous space where mechanics made judgment calls about acceptable risks based on incomplete information and immediate pressures. Luke returned to civilian life after the war and worked as aircraft mechanic for commercial airline, applying skills developed during military service to maintaining passenger aircraft under very different safety standards. The airline maintenance was frustrating because it required following procedures precisely and didn't allow the improvisation that had characterized wartime maintenance. Luke understood that passenger safety required stricter standards than military operations, but he missed the creative problem-solving that had made wartime maintenance intellectually engaging, despite being constantly stressful. He rarely discussed the leather tank modification in civilian context, because explaining it required contextualizing parts, shortages, and operational pressures that civilian audiences found difficult to understand. When he did describe the modification, reactions were usually shock that military maintenance had accepted such obvious safety compromises, shock that he had risked his own life testing fuel tanks constructed from leather and hope rather than from engineering analysis and proper materials. The shock reflected different safety expectations between civilian and military aviation, but it also reflected misunderstanding about how wartime constraints made impossible choices routine rather than exceptional. The leather tanks themselves didn't survive beyond their operational use. When they were replaced with proper metal tanks, the leather versions were discarded as waste materials rather than being preserved as historical artifacts. The physical evidence of the modification existed only briefly during the months when specific aircraft carried leather tanks, then disappeared completely when those tanks were removed and destroyed. The lack of physical preservation was typical for improvised wartime solutions that served immediate purposes but weren't considered worthy of long-term documentation or memorialization. The technical documentation Luke had written describing leather tank construction procedures was preserved in maintenance archives and was eventually declassified in 1980s when its operational significance had expired. Aviation historians discovered the documentation and were fascinated by the modification as example of field improvisation that demonstrated how maintenance personnel had kept aircraft flying despite supply chain failures that should have grounded significant portions of bomber forces. The documentation became research material for studies about logistics and improvisation and the relationship between formal procedures and practical problem-solving under resource constraints. Modern aviation safety standards would absolutely prohibit leather fuel tank modifications under any circumstances. The materials science and engineering analysis capabilities available today would demonstrate definitively that leather tanks were dangerous far beyond what wartime testing had revealed, would show failure mechanisms that Luke couldn't have detected without equipment and analytical methods that didn't exist in 1944. The modern analysis doesn't diminish Luke's innovation, but it contextualizes why the innovation worked. Not because it was safe, but because luck and limited operational use prevented the failures that more extensive deployment or longer service life would almost certainly have caused. The bomber groups that benefited from leather tank modifications never knew specifically which aircraft had carried improvised fuel systems or which missions had been flown using leather tanks that might have failed catastrophically. The operational security that kept technical details classified also kept crews uninformed about modifications that affected their survival probability. The information gap was ethically questionable, but operationally necessary. Crews who knew their fuel tanks were leather might have refused to fly, might have lost confidence in maintenance operations, might have made risk calculations that would have degraded unit effectiveness. Luke's commanding officer, who had approved the operational deployment of leather tanks, was investigated after the war by board examining maintenance procedures and safety standards during combat operations. The investigation concluded that the decision had violated regulations but had been justified by operational necessity, that the commander had made reasonable judgment call given information available and pressures that existed at time. The investigation's conclusion essentially validated the ambiguous space where field commanders made decisions that regulations said were wrong, but circumstances said were necessary, validated the reality that warfare consistently created situations where no choice was clearly correct, and where commanders had to accept responsibility for decisions that might be second-guessed regardless of outcomes. The 35 bombers that received leather tanks flew collective total of hundreds of missions after the modifications, completing operations that contributed to Allied victory in ways that couldn't be isolated or quantified. The contribution wasn't dramatic or decisive, but was incremental. Each aircraft that remained operational rather than being grounded increased bomber formation strength by small margin that slightly improved crew survival rates and slightly increased bombing accuracy. The small margins accumulated across hundreds of missions into effects that mattered, even though specific cause and effect relationships couldn't be demonstrated definitively. The mechanics who had learned leather tank construction from Luke's training generally didn't use the technique after the war ended and supply chains normalized. The skill remained in their repertoire, but became obsolete knowledge that civilian aviation would never permit, and that military aviation hoped would never again be necessary. The obsolescence was positive development. It meant supply chains were functioning well enough that desperate improvisation wasn't required, but it also meant knowledge that had been operationally crucial was becoming historical curiosity rather than living practice. Luke died in 1973, without achieving prominence beyond his professional circle, without receiving public recognition for innovations that had kept bombers flying during critical phases of the air war over Europe. His obituary mentioned his civilian aviation career and his military service, without specifying his role in developing improvised fuel tank modifications that had violated safety standards while saving aircraft that otherwise would have been grounded by parts shortages. The omission reflected how technical innovations often remained unacknowledged compared to combat operations and strategic decisions that received extensive public attention. The leather tank modification represented intersection of desperation and creativity, where impossible constraints forced unconventional solutions that worked despite violating every standard that governed normal operations. Luke had taken leather intended for tool pouches and transformed it into fuel tanks through improvisation that combined multiple skill sets and multiple knowledge domains in ways his training had never anticipated. The transformation succeeded not because it was safe or proper, but because it addressed immediate problem using available resources within unforgiving timeline that eliminated any option for perfect solutions. The specific bombers that flew with leather tanks were tracked inconsistently through maintenance records that prioritized operational readiness over historical documentation. Some aircraft carried leather tanks for single mission before receiving proper replacements. Others operated with improvised fuel systems for weeks before metal tanks became available. The variation made safety assessment difficult because short-term use might hide failure modes that longer deployment would have revealed, made risk calculation impossible because statistical sample was too small and too inconsistent for meaningful analysis. Luke had created solution that worked within the operational context where it was used, but which couldn't be validated through methods that engineering standards would have required. The pilots who flew bombers with leather tanks developed informal network sharing information about how the improvised systems behaved, sharing observations about fuel pressure characteristics and warning signs that might indicate imminent failure. The informal knowledge sharing operated outside official channels because acknowledging leather tanks too explicitly would have drawn attention from safety officers who might have prohibited modifications that operational commanders wanted to continue using. The unofficial nature of the information network meant that critical operational knowledge was being preserved and transmitted through personal relationships rather than through formal documentation that would have made the information accessible to everyone who needed it. The engineering officers who eventually investigated leather tank modifications after supply chains had improved were conflicted about what they found. The modification clearly violated safety standards and clearly had worked without causing catastrophic failures that safety analysis predicted. The contradiction between predicted danger and actual performance suggested either that safety analysis was overly conservative or that Luke and the other mechanics had been extraordinarily lucky. The engineering officers couldn't resolve the contradiction definitively because comprehensive testing would have required resources that weren't available for studying modifications that were already being phased out as proper parts became available. The debate about whether leather tanks should have been prohibited or whether they represented acceptable risk management under wartime constraints continued through post-war analysis and never reached definitive conclusion. The debate revealed fundamental tension in military operations between following established procedures that minimized risk and adapting procedures to circumstances that made standard approaches ineffective. Leather tanks became case study used in military logistics training to illustrate that tension, to demonstrate that neither rigid adherence to procedures nor complete abandonment of standards was appropriate response to operational constraints that made perfect solutions impossible. Luke's role in developing and deploying leather tank modification was preserved primarily through maintenance records and through interviews with personnel who had worked with him during the war. The interviews revealed that Luke had been deeply concerned about safety implications of his modification, had conducted testing that went beyond what immediate pressures would have required, had documented limitations and inspection requirements with attention to detail that suggested he understood the risks he was accepting. The concern demonstrated that improvisation under pressure didn't mean abandoning safety considerations, but meant making different risk calculations than peacetime standards would have permitted. The bomber crews who survived missions flown with leather tanks never learned that their survival had depended partially on fuel tanks constructed from materials that peacetime aviation would have considered absurdly dangerous. The ignorance was probably fortunate, because knowing might have undermined confidence in maintenance operations, might have created anxiety that would have degraded crew performance during missions that were already extraordinarily stressful. The decision to keep crews uninformed about technical modifications was ethically ambiguous, but operationally defensible, given that crew morale depended partially on believing that their aircraft were properly maintained and that safety standards were being followed even when operational reality made full compliance impossible. The parts shortage that had prompted leather tank development continued throughout 1944, despite supply chain improvements, continued because submarine warfare disrupted shipping and because production capacity couldn't meet demand from multiple theaters simultaneously. The persistence meant that improvised solutions remained necessary even as official channels kept promising that proper parts would soon be available, meant that mechanics like Luke continued developing modifications that regulations prohibited but operations required. The gap between official promises and operational reality was characteristic of wartime logistics, where planning assumptions consistently underestimated actual requirements and where field operations had to adapt to shortfalls that higher command levels acknowledged reluctantly, if at all. Luke's training program for other mechanics who wanted to replicate leather tank construction revealed significant variation in craftsmanship that affected tank quality and reliability. Some mechanics produced tanks that Luke considered adequate for operational use, while others produced work that he rejected as unsafe, even by the relaxed standards that desperation had made acceptable. The quality variation demonstrated that improvised solutions couldn't be replicated mechanically through following procedures. They required judgment and skill that varied across individuals, and that determined whether improvisation produced functional equipment or dangerous failures. The recognition that improvisation required craftsman-level skill rather than just technical competence influenced post-war training programs that began emphasizing practical problem-solving and adaptability rather than just procedural compliance. The resin compound Luke used for sealing leather tank seams was commercial product intended for boat construction, was material he had requisitioned from civilian supplier without proper authorization because military supply channels didn't stock materials for unauthorized modifications. The unauthorized requisition created administrative complications when supply officers discovered the procurement and demanded explanation for why boat-building materials were being ordered for aircraft repair facility. Luke's explanation that he was using resin for fuel tank construction was met with disbelief, followed by investigation that ultimately concluded the requisition had been irregular but necessary given operational circumstances. The investigation became another example of how improvised solutions created administrative tangles that had to be resolved through chains of command that weren't designed to handle innovations that violated standard procedures. The leather tank modification influenced how subsequent generations of military mechanics approached problem-solving under resource constraints. The modification demonstrated that materials could be repurposed for uses their manufacturers had never intended if you understood material properties and engineering principles well enough to adapt them to new contexts. The lesson was valuable because military operations consistently occurred in resource-constrained environments where standard solutions weren't available and where survival required creative adaptation of whatever materials could be obtained. Luke's leather tanks became example taught in maintenance training courses as illustration of how improvisation could extend operational capability when supply chains failed to deliver required materials. The safety debate about leather tanks also influenced development of military aviation safety standards that attempted to create frameworks for evaluating improvised modifications systematically, rather than prohibiting all deviations from standard procedures. The frameworks recognized that absolute prohibition of field modifications was unrealistic because operational pressures would continue forcing improvisation regardless of regulations, recognized that better approach was establishing criteria for when modifications were acceptable risks versus when they were unacceptable dangers. The criteria were necessarily imperfect because they required predicting safety implications of modifications that by definition were novel and untested, but they represented an attempt to systematize decision-making that had previously been purely judgmental. The specific leather treatment process Luke used to make material resistant to gasoline dissolution was never fully documented because he had developed it through experimentation rather than through following established procedures. The process involved tanning treatments and surface coatings that Luke had learned about from civilian leather workers and had adapted to aviation fuel requirements through trial and error. The incomplete documentation meant the technique couldn't be precisely replicated by others without similar experimentation, meant the modification remained partially dependent on Luke's individual expertise, rather than being fully transferable knowledge. The limitation was frustrating for military logistics that preferred standardized procedures, but it was characteristic of how improvised solutions often remained, dependent on individual craftsmen who had developed them. The bomber groups that received aircraft with leather tanks generally achieved mission success rates comparable to groups flying aircraft with standard fuel systems. The comparable performance suggested that leather tanks didn't significantly degrade operational capability, even though they created additional maintenance burdens and safety concerns. The performance data was reassuring but insufficient for definitive safety assessment because the sample size was small and because many factors besides fuel system reliability affected mission outcomes. Luke and other maintenance personnel who had implemented the modification considered the comparable performance as validation that their improvisation had been reasonable engineering response to impossible constraints rather than reckless disregard for safety. The administrative burden of tracking which aircraft had leather tanks and ensuring proper inspection schedules were followed consumed maintenance officer time that could have been devoted to other priorities. The burden demonstrated that improvised solutions created hidden costs beyond the obvious technical challenges, created management overhead that had to be absorbed by operations that were already stretched thin. The recognition that improvisation wasn't free, even when materials cost was minimal, influenced post-war logistics planning that attempted to account for management costs associated with non-standard modifications, and that attempted to reduce those costs through better documentation and tracking procedures. Luke's test flight with the prototype leather tanks remained one of most dangerous activities he participated in during the war, despite occurring in relatively safe training environment rather than in combat conditions. The danger came from knowing that fuel system failure at altitude would probably be fatal because fire would spread too rapidly for bailout to be a viable option, came from accepting that risk based on calculations that suggested failure was unlikely but not impossible. The willingness to accept that risk demonstrated commitment to finding solutions that would keep aircraft operational rather than accepting that parts shortages meant inevitable grounding of damaged bombers. The commitment was admirable, but also troubling because it normalized risk acceptance that peacetime operations would have considered unacceptable. The commanding officer who approved Luke's leather tank modification for operational deployment continued his military career after the war and eventually reached general officer rank. His post-war career was successful despite the investigation into his wartime decision-making about leather tanks, because investigators concluded his decisions had been reasonable given circumstances and constraints that existed during combat operations. The successful career suggested that military services recognized distinction between decisions that violated regulations for good reasons versus decisions that violated regulations through negligence or incompetence. The recognition was important for maintaining operational flexibility because absolute enforcement of regulations, regardless of circumstances, would have prevented adaptations that were sometimes necessary for mission success. The leather tank's operational use ended gradually through 1945 as supply chains stabilized and as proper metal tanks became reliably available through normal procurement channels. The gradual phase-out meant there was never a definitive moment when the modification was discontinued. Individual aircraft received metal replacements as those parts became available. Individual mechanics stopped constructing leather tanks as the need diminished. The technique simply faded from use without formal declaration that the improvisation period had ended. The informal ending was characteristic of how many wartime expedients disappeared as circumstances improved without leaving clear markers indicating when emergency measures had transitioned back to standard procedures. The institutional memory of leather tank modification persisted primarily among maintenance personnel who had directly participated in the innovation and who shared stories about the technique with younger mechanics who joined military service after the war. The stories emphasized both the technical cleverness of the solution and the safety concerns that had made it controversial, emphasized that improvisation had been necessary response to specific circumstances rather than general approach that should be replicated casually. The balanced perspective was valuable for training because it acknowledged both the value and the limitations of field improvisation, acknowledged that similar creativity might be necessary in future conflicts, while also emphasizing that improvised solutions should be temporary expedients rather than permanent practices. Luke's personal tools and equipment that he had used for constructing leather tanks weren't preserved as historical artifacts because he had continued using them for normal maintenance work after the war ended. The tools were ordinary implements, stitching needles and cutting tools and measuring devices that had no distinguishing features indicating their role in creating improvised fuel tanks. The lack of physical artifacts meant the modification existed primarily in documentation and memory, rather than in preserved objects that museums could display, meant the innovation was more difficult to communicate to audiences who needed tangible evidence to fully comprehend historical events. The technical specifications Luke documented for leather tank construction were written in style that assumed readers had basic understanding of both aircraft fuel systems and leatherworking techniques. The assumption made the documentation difficult for people who lacked one or both knowledge domains to interpret without additional context, made the specifications less useful than they might have been if Luke had written them for readers with diverse backgrounds. The limitation was understandable given that Luke wrote documentation under time pressure for immediate operational use rather than for long-term historical preservation. But it meant later researchers struggled to fully understand the construction techniques without conducting experimental archaeology that attempted to replicate Luke's methods through trial and error similar to his original development process. Modern materials science analysis of leather's properties as fuel container material confirms that Luke's modification was substantially more dangerous than wartime testing revealed. Leather's organic composition makes it susceptible to chemical degradation from hydrocarbon exposure, makes it vulnerable to catastrophic failure modes where material strength deteriorates rapidly once degradation reaches critical threshold. The analysis suggests Luke was fortunate that operational use remained limited enough that most leather tanks were replaced before reaching the point where catastrophic failure became probable rather than merely possible. The fortunate timing was probably a combination of luck and conservative replacement schedules that Luke had recommended based on his understanding of material limitations, even though he lacked analytical tools to precisely characterize those limitations. The bomber crews who flew missions with leather tanks included personnel who later became prominent in civilian aviation industry and in military leadership positions. Their experiences with improvised modifications influenced their later attitudes about balancing safety requirements against operational flexibility, influenced their understanding that perfect safety was sometimes incompatible with mission accomplishment. The influence was subtle because most crew members never knew specifically about leather tanks, but their general exposure to maintenance improvisation during the war shaped their expectations about what was achievable when resources were limited and when circumstances demanded solutions that standard procedures didn't accommodate.